So here we have a number of video streams from traffic cameras monitoring a number of places around a housing estate. As you can see, there's vehicles moving through the housing estate, and we want to track a suspicious vehicle as it is detected by these multiple cameras located in different locations. Not only do we want to track the location of the vehicle and identify the vehicle as a particularly suspicious vehicle, we then want to notify the police and the nearest police officer to intercept the vehicle. Here we have a model of our application. So we have our traffic cameras as inbound events, generating our object recognition events. Now, the cameras and the events that are being generated contain coordinates of the identified object, in this case a car, but the coordinates are based on the coordinates within inside the actual image. So we need to first convert those coordinates into geospatial coordinates. So we need to convert the XY coordinates from the image into physical locations within a space. Once we've done that, we're going to check to see if this particular vehicle is a suspicious vehicle. If it's not, no action is required. If this vehicle is suspicious, we want to start tracking this vehicle across the multiple camera streams. At the same time, we're now going to generate a suspicious vehicle event, notify the nearest police officer, sending a pursuit request. If nobody responds to this pursuit request, we want to escalate this to the control room and send them a notification. If a police officer responds, then we're going to send them some real-time tracking information. This application is generated from this model. So within the generate capability of the system modeler, we can specify the type of activity each of these reactions is. So in this case, this is going to be a convert coordinates. In this particular case, it's going to be a track motion. This generates the following application. And this is a visual representation of the flow of events and the actions that are going to be performed upon those events. So the first thing we're going to do is add camera details. We'll come back to this later. Then we're going to convert the coordinate system. So here we're going to specify how we convert the XY coordinates of the image into longitude and latitude coordinates. Okay, so we need to specify the XY coordinates and the longitude and latitude coordinates. And this will generate us a new event with the coordinate system converted to GeoJSON. Then we need to check to see if this is a suspicious vehicle, and then we need to start tracking this particular vehicle using the track motion activity pattern. So we're going to specify a number of parameters here, things like how long is this vehicle going to be. If we don't see this vehicle for 5 minutes, we're going to declare this vehicle as absent in the various streams. We're going to build the path. So what build path will do is generate a path that this vehicle has taken across these various video streams. So using the coordinates that have been converted to GeoJSON, we can now generate a path that this vehicle took. And then finally, we're going to start a collaboration. Now, inside the application builder, there's a missing step. When we track the vehicle, we want to track a particular vehicle, and at any given time, we may be tracking multiple vehicles. So the track cars and the build path are vehicle specific. So we need to do what's called a split by group. So within here, we can just drag and drop this split by group onto here to say, insert this in the middle. And the split by group takes a parameter which says, how am I going to split this? So I'm going to split this by the results dot label. So each particular car is going to be tracked separately. Now, once a suspicious vehicle has been detected and it's being tracked, a collaboration will be started. The collaboration is built in very much the same way. The collaboration is built through this drag and drop interface through Collaboration Builder. And once again, this initial collaboration was built automatically from the system model. And each of these activity patterns takes a series of parameters. So this particular activity pattern is a recommend. So it's going to say use the built-in procedure called nearby recommendation, and what it's going to recommend is police vehicle. So it's going to recommend the nearest police vehicle to the particular car being tracked, and the car in question is coming from the suspicious vehicle's current location, which is being updated in real time as the vehicle is detected in different video streams. Once we've recommended the nearest police vehicle, we're going to assign that police vehicle to the collaboration, and we're going to send out a pursuit request. Once that vehicle accepts that pursuit request, we're going to send a second notification, which is the send tracking notification. In this case, it's going to send it to the police vehicle, and what it's going to send is the tracking notification client, passing in a number of parameters like the license plate, etc., of the car that's being tracked. If nobody responds to this pursuit request, then we have an escalate. If they don't respond within a few minutes, then what we're going to do is escalate this to the control room. Once the police vehicle has intercepted the suspicious vehicle, the police vehicle will send a notification back to say they've intercepted it, everything is to be closed, and the collaboration will be shut down. So as we can see here, the application is running, camera events are being generated. We're looking for our suspicious vehicle. At the moment, the suspicious vehicle hasn't been detected, but in a few seconds, the suspicious vehicle will be detected. The vehicle in question will start being tracked, and the collaboration is started. In a few seconds, the suspicious vehicle will be picked up by a second camera 2. Here we go. And now the vehicle is being tracked still. The collaboration is open, and that vehicle in question is now being tracked and has been sent to the police. So if we look here, this is our notification that was sent to the police officer with the license plate, the model and make, a picture of the vehicle, and also the current location of the vehicle and details of the path of the vehicle in question. Once the police officer has intercepted the vehicle, we can click the intercept button and the application completes. As well as building applications through this very low code model driven approach, it is also possible to add code to this application. So the add vehicle, for instance, executes a built-in procedure. This particular built-in procedure is going to use what's called vision scripts to manipulate the image. The image that comes in is rather large. We want to crop the image, and then we want to interact with, in this case, Sighthound to gather additional information about the car. For instance, the license plate number, the model, and the make.
Vantiq. Innovate faster. Operate smarter.